Hi, everybody. It's very nice to see you here. I'm Mirna from Speckle. I'm the content manager, and thank you so much for providing beautiful content lately to get it very, hyped up about SpeckleCon, because it is a thing to, get hyped up about. And I wanted to get up here to hype you up about a very special talk today, because it's not just something random. There's a few reasons why this is very special. First of all, this person here came all the way from Cape Town to be here with us. So it's, yeah. And another even greater thing is just a few weeks ago, James became a father, so this is even more special for him. Yes.
Thanks.
And the third reason, you're going to see Speckle Automate in action in real life. So stay tuned for James from Zutari.
Thank you very much.
Thank you so much.
Thank you for that introduction, Mirna. So I had a joke that I wanted to share with everyone, and I was like, maybe I won't do it, I won't mention it. But since Mirna mentioned the fact that I recently became a father, so I'm a computational designer, and one of the things that entails is creating workflows that are as streamlined as possible, that are efficient, and that make everyone using them as comfortable as possible. And I never knew that skill would come so in handy when it came to changing a diaper, because that is one workflow that really needs to be very efficient, and the client that you're dealing with needs to be as comfortable as possible, because he will let you know if he's not. So yeah, thank you for that, Mirna. It's an absolute honor to be here today presenting to you. I'm going to be walking through a workflow that I developed at my company, a workflow to streamline the report writing process with Speckle. And this is born out of the initiatives from Zutari, the company that I'm working for, to become a fully digital practice by 2025. So with that, before I start, I would just like to give a little bit more of a background of myself, as well as the fantastic company that has given me this opportunity to present to you today. I really like helping people and helping them to have workflows that prevent them from doing boring, repetitive work. I don't want anyone to be stuck in the same repetitive work over and over again, because I'd like them to focus on the interesting, creative things where that breeds innovation within your company. If everyone's stuck doing the same thing over and over again, then we get tired, we stop thinking of new ideas, and it's that creative stuff that really gets us up in the morning and gets us to work and doing the amazing things that our industry can do. So that's why I became a computational designer. My background is in structural engineering, as well as I have experience in software development, where I can now use the statistical analysis learned at the software company that I worked for, as well as new computational methods to try and solve these engineering problems that we all face. So, and as well, Jonathan and, sorry, I forgot your name. Chuck. Yeah. Chuck, they mentioned that they were Speckle fans, and I'm definitely a Speckle fanboy. When I started as a computational designer, it was one of the first pieces of software that I started to really get to use and try, and I started with the interoperability side because I had a project that needed a ETABS model brought into Revit so that we could have a look at what was going on and try and speed up the initial design initial modeling process because we had an ETABS model and we wanted to have a Revit model for the clients. So that's my background. Zutari, the company that I'm working for, is an infrastructure engineering and advisory practice, and I'm specifically located in their Global Design Center, or GDC for short. I may say GDC a couple times rather than Global Design Center. This unit within Zutari delivers large, complex projects to clients anywhere in the world, from a football stadium in Australia to mega towers in Dubai. The GDC has a wide range of projects that are flowing through its doors. And these projects, they vary across many different markets, which has led us to focus on a digital-first approach on every project so that our team can deliver the quality of work expected of us for clients anywhere in the world. And this is where this workflow was born. The projects we face have become more complex, and the deadlines that we are required to produce these these projects in have become shorter. This is not unique to Zutari. This is an industry trend. However, embracing the future today by creating these workflows is key to delivering these projects on time and under budget, which leads us to the purpose of this talk. I would like to start with the traditional way that we would normally deliver a project like I will mention today, then move on to how Speckle has been used to challenge the status quo of other softwares by focusing on storing the object data between different steps in the process, and then finally have a look at the results of the workflow and how it has impacted our work. So without further delay, let's have a look at the project. At a first glance, the project seems simple. It's a structure that is a suspended roadway made up of a series of interlocking steel trusses. The main deliverables that we were required to produce were to review the design reports and produce our own reports to verify the original consultant's design. Simple in theory, but the original consultant had 6 years to do the work, and we had 2 months. So that made the process a little bit more complicated. The reason being is that the structure had no regular trusses on which a simplification could be made. Therefore, all 70,000 elements of the structure, which was 400 meters long and 200 meters wide, had to be individually designed. This was equivalent to taking the Eiffel Tower, turning it on its side, and suspending it 64 meters up in the air. We needed a good workflow. In order to deliver the work traditionally, in order to deliver the work, we needed to deliver two visualizations. A 3D representation of the structure with certain elements highlighted, and then a 2D chart that spoke to that 3D image that had the design properties behind it. The traditional method that we started with began in a structural analysis software where every element in that model would be modeled, analyzed, and then designed. Then, due to the complexity of the structure, there were a lot of small revisions that needed to be made because obviously something can be missed. There is sometimes a design iteration where let's try this, let's try that, and a lot of iterations were created, and this led to a very fragmented file structure where we had a number of model variations, number of calculation files, and many, many reports. Then from these separate data sources, we had to do Excel data dumps to begin to classify the elements that we would look at to verify their design. Then often these Excel files became very large, 70,000 elements. Each element has a number of different rows in a side, and these Excel files would quickly reach their row maximums, so we had to then duplicate those files, and even more Excel files were created. And now if anyone has recently tried to save a file in Excel will know finding the correct path on where to save that and also implement some sort of naming convention becomes a very time-consuming process, and especially when you have to do that for every variation of the project. So we got our 2D charts in that method, and finally the 3D elements needed to be exported and classified manually in a 3D design software such as Revit or Rhino. And once all of this was tested, verified, and made it into the report, an iteration was given and we would have to do it all over again. We quickly found that there were several problems that we were facing. There were too many files that needed to be managed between team members, leading to version control issues and incorrect save locations. And if that was done correctly, a version would be updated and that would all be superseded. For every iteration, the update to the report required a lot of manual rework because files needed to be linked to new versions, and often incorrect data could be extracted from the analysis software because there's so many different filters and parameters to select that it's very easy to select the wrong one, and then you have to traverse through every single Excel file to find which file is broken and export that data, or just sometimes it's easier just to start again, and hopefully that's not at the last step. Finally, the work that one person did was very difficult to transfer from one team member to another, because when you transfer Excel files to different computers, the file linking and file paths often would break. And we tried a number of different iterations to fix that, but those all add complexity and extra manual steps that we needed to show every new user. So clearly we needed something different because that wasn't sustainable. So we took some time to think of some solutions. Firstly, we thought of writing we started writing a Python script to automate the file extraction from the analysis software. However, this became very difficult to share between team members because not everyone had Python installed or the correct libraries, and then when the script had an updated version, you had to also give that to everyone in your team, and that can become quite difficult to do. Secondly, we tried to standardize the exports from the models. There is a function to save export configurations inside of in the analysis software we were using, which was SAP 2000, which is a CSI product. But unfortunately, because there were so many stakeholders and so many models, it was very difficult to send that across to every single model, and we often ended up having to just do it manually anyway. And finally, we looked at adding more resources to the project, but as I've mentioned so far, adding more resources becomes difficult because there's more things that can go wrong based on the workflow that we had. So it was generally one person had to sit and grind through the whole extraction process, the whole cleaning process, and the whole report writing process because it all had to be on their one computer. So here we can see how the data stored in multiple places as different objects, such as Excel files, model files, and on SharePoint, makes it difficult to collaborate and as well as even automate this workflow. And that's why we turned to Speckle, not just because I'm a fanboy and I had wanted any excuse to work on Speckle on a project, but that we could use it as our central data storage as well as a platform to host the automations that we were developing. We liked the fact that the models could now be stored with their version histories all tracked without having to save multiple files. This meant also that anyone who would be new onto the project would immediately be able to see the most up-to-date versions or have a look back over the history of the project. Then, without the need for manual input from a user, automations could be run automatically, and the process of classifying the elements, which I mentioned earlier, would happen seamlessly without anyone needing to really think about it. And furthermore, the work put into the Python scripts that we had already started to develop could be reused in the Speckle automate function without needing to do too many changes to that. And with those things in place, now updates were at this point in the project were likely to take hours instead of days. So on a high level, this is what the workflow looked like with Speckle. Again, we started with analysis software. We had our data inside of the analysis model that flowed or was sent to Speckle, where the automate function would run and classify the data, and then finally the visualizations were ready for the report. This process runs on every model change without the need for any user input, and that meant that things could happen a lot more quickly. Now let's take a look at each of these steps a little bit more closely. First, we need to get the data out of the model and into the Speckle viewer. For the purpose of this presentation, we'll just highlight a key piece of the structure. With the initial setup process, we used the Speckle connector to send the model to the correct location. Thereafter, that setup was done. We didn't need to do that again. In general, the send process was relatively quick, and anyone doing it could work in parallel on other work while that was happening. Then, once it was sent, we were able to view the original non-classified data that was sent. I'd like you just to note the fact that there is no classification parameter there, as well as all the line elements stored in Speckle were 1D line elements. This step greatly helped already to reduce the amount of manual work that was needed and reduce the time to get the data out of the model. Next, we needed to use the Speckle platform to classify the elements. Once the new data was sent to the viewer, the automate function would run without the need for manual input and created a new model in the Speckle viewer. Notice with that new model that there is now 3D geometry data as well as a classification parameter that is assigned to each element in the model. This classification, as I mentioned earlier, was used to display the elements with their classification type to simplify the amounts of data to show on a visual. Because we couldn't just show the entire structure, it was too big and too difficult to show that all on one plot. So we needed to break the structure down into 3 classifications, either vertical elements, diagonal elements, or horizontal elements. Automate was able to do this through a Python script by looking at the element's position and their direction to classify them and update the Speckle object and send that back to the Speckle viewer. We now had the ability to see the original as well as the new updated object and either compare the two to verify that it ran correctly or to run any other processes on the original data or the classified data. And this is great and all, but we still need to find our 2D chart out of all of this. Luckily, Speckle had a connector for this, so we used the Excel connector to receive the data from the classified model. We were able to filter the Speckle data into the 2 parameters that we needed, which was the name of the element as well as the classification. And thereafter, the data was received into the export data the Speckle classified data was received directly into the structural data that was exported directly from the analysis model. This meant that there was no more need for large Excel files that needed to classify the data, as well as allowed for the classified data to be used by multiple different users. And we didn't need to make any copies of that data. It could just be received through the Speckle connector. This shows the importance of storing the object data between steps because it reduced that manual rework of saving and copying the data. One thing I wanted to mention after seeing that initial keynote was this process of what I think when I get home, I'm definitely going to go and try and implement this into Power BI as well and add maybe one of those embedded Speckle viewer into the site. I think the client will definitely like that. Then the finished product looked like this. We had on the right, you can see the 2 visuals that we got from the automate function and inside a Speckle viewer, as well as pulling it into our Excel sheets. And then on the left, this is how it was utilized in the reports. The 3D graphics above showed the elements that were displayed on the charts and the properties that were, or the values given to those elements on the chart would speak to the same elements on the 3D charts, 3D graphics. And now that we have this workflow, we needed to ask whether it was even worth the effort of developing it in the first place. When we look at the geometry, any updates to the geometry and the classification worked as expected when we started the development. It was now possible to have more clarity on what the classifications of those elements look like by comparing the before and the after. Updates to the classification could now take minutes instead of hours that it used to take, and the classification and using the classification to produce the charts would take a third of the time than what it would originally take us to implement. This was mainly due to the reduction in manual rework. And with the Speckle viewer, both the original data and the classified data were stored in the same location, which allowed for easy verification of the data by multiple users, and it's easy to share the data between different users. Then an unexpected benefit that we also found from working on the Speckle platform was the fact that all the code and all the development was stored on GitHub. It meant that the work was never lost, that if someone needed to pick it up and work on it, or if someone left, the work would not just die in a folder structure somewhere. Finally, one thing to note about workflows like this, however, is that it can seem like a bit of a black box to the user actually using it. All they see is some input and they get some output, and they have no idea how it gets there. Luckily for this workflow, the results are very visual, so you can view it in the Speckle viewer and compare it and make sure that the results that you get are verified. But that is something that we would consider in implementing any workflow with the Speckle Automate or anything like similar to this. So the answer to the question of whether it was worth it is definitely a resounding yes. The effort was worth it. Storing the data in one object greatly reduced the amount of rework and allowed for the work to be shared more easily. And if there are any projects like this, we're definitely going to look at implementing either the same workflow, which can be very easily adapted to other workflows or other disciplines. It's not necessarily a structural specific one. The beauty of this workflow, and I think it's the same for most automate functions, is that it's just the function. If you can adjust the classification to look for other elements, or if you adjust what classification you need, you can apply this to many different disciplines or many different kinds of objects. So the work that we did was not unique to this workflow, but we'll definitely use it in future workflows for other projects with similar characteristics or similar deliverables. Thank you for being here and hearing my presentation. I hope that it was a good taste of the future today, and that the ideas and principles from it will be a good seed to help the Speckle flower grow into throughout the rest of this conference. If you would like to reach out to us regarding this workflow or to find out more about what the Global Design Center does or what we do at Zutari, please feel free to take a picture of the slide and get in contact with us. We'd love to chat, and our computational design team is very friendly, and we love working for many different clients all over the world and delivering amazing projects. So thank you very much.
Thank you, James. Yes.
Anything like that, I'll happily stay here afterwards or now.
Stick around, James. If anybody has any questions for James, I'm going to run up to you so you can say it louder. Let's go. It's going to be tough. All the way there.
I'm sure the sound engineer just cringed as you threw that.
Thank you very much for that. I really enjoyed watching that. I thought it was very interesting. I've always sort of thought that using text-based workflows and having this kind of AEC automation would be amazing. And seeing someone do it is like, oh, it actually works. Wow.
Awesome.
So one thing I'd love to know is, every project I've ever done in AEC, Someone gives you the project, you go, right then, you figure it out, and then you toss it and go to the next project. How much more reusable did you find this than maybe other projects that you've done?
So I think the key reusability is the fact that it's all open and available for anyone to see and available for the business to actually implement and to tweak. Generally what happens is an engineer or someone working on a project will work on it on their own computer. They'll do something amazing and all we'll see is the end point. And they're like, oh, well, that guy's really amazing. We're going to use him on the next project, but we have no idea what he's doing. Where doing it this way, it's a bit more out in the open for everyone to see. And the more public we are about what we're doing, the more people will be able to use it and implement it on different projects.
Right, so those wonderful little scripts someone comes up with per project, those are kind of broken down and then they're actually put somewhere useful so they don't just end up lost to the sands of time, or they drop their laptop in a bucket and that's just gone now kind of thing.
Exactly. Something that we have implemented at Zutari is everyone who knows how to code and is coding, they are part of a GitHub account. Any code that they write can go up to that GitHub account, even if it's the simplest script of hello world or whatever. We tell them just send it all there and store it there, because that's hosted and managed by the company. So the company has access to all of that, and everyone else can see the work that they're doing. That's how we make sure that the scripts that we do use are shared amongst others in the company.
Very cool, thank you.
You're welcome.
Thank you so much for the question. Anybody else? I have one more.
Thanks, James. Very quick question. I can tell that was an early stage design, early stage structural design. Would you say that the same workflows can be applied to detailed design?
To detailed design. It depends on what specific in detailed design, I would say. I'd have to probably think about it a little bit more, but I think what I said at the end, where whatever the classification is, whatever the script that you need to run is, it's very easy to take a look at it and to adjust it to what you need. So if from a structural, which I understand a little bit more, for a connection design or things like that, you can definitely would be able to say, go in and have a look at specific elements or find places in your structure with an automate function or a script like that where you would need to focus your design and focus your parameters. For example, if there was a certain area in the structure that was highly utilized, you could highlight that and say, look, this is where you maybe need to focus your design first and optimize there. Or vice versa, if there was very low utilization, you could say, go look and optimize these elements and you will get a better result overall.
Thank you.
Sure.
Thank you for the question.
James, quick questions. Well, in your experience, for someone that hasn't worked with the Speckle platform, doing custom Python scripts, how long would it take to put something in there, going through documentation, kind of learning the API and putting your own custom workflow there? Is it something that it would take you a week, a month? I don't know.
So I hadn't done any Speckle Python scripts or anything. I know Python and new programming and things like that before going into this, but without having used the Speckle platform and the Speckle objects and things, it isn't a very high barrier to entry, but your greatest asset will be the Speckle team themselves. I worked very closely with Bjorn on a lot of the work. There's a lot of examples available, and if you can see who made the example, you can always contact them from the Speckle community, and that is your best entry point, and they will point you to where you should look and things, and that helped me the most. So I'd say the turnaround time from 0 to getting something working is maybe a few days of solid work. If you can spare full days, you could probably do it in three days or so. Because the function itself, there's nothing special about the function. It's just give it some input and take some output. That's something you can develop off Speckle. It's just understanding how the Speckle object works and how to use that data. That's the trick. And once you know that, then you can do anything.
Thank you so much.
You're welcome.
Look at the Speckle support team blushing here. Thank you, James. We have one more question. Let's meet in the middle. Here you go.
Hi, great presentation. I'm curious to know, have you considered like chaining structural analysis or compliance in the modeling? Like how would if you model in ETABS and using Speckle Automate, do like all the structural analysis using the Python logic, and if you model and if a beam fails, also getting alerts.
So do you mean taking the analysis or taking the design outside of the analysis software and putting it onto Speckle instead? So Bjorn actually has done something similar for a column design, but that's definitely an end goal for, I think, a lot of companies, because we want to design things in the way that makes sense to us and what we believe to be as safe as possible, and to any different design codes. And often software can either be very vague about how they do that, or they can change it and you might not trust the result. So any Python design script that you have, it will obviously take some sort of input and get some sort of output. So you can add that into a little package, put that into your automate script, and whatever you send up to Speckle, correct me if I'm wrong, Born, you get all the forces from within a element. So you get all the element forces, all the things you need to do to then run the design. And that will then allow you to do any kind of design you would like on the Speckle viewer. How you present that, that's also up to you, but you can do it, for sure.
Amazing, thanks.
Sure.